Calculations based on equilibrium constant value. A reaction mixture is prepared by taking 4 mole of NO2 gas and an unknown amount of N2O4 gas in a closed vessel of volume 4 decimeter cube. The chemical equation is 2NO2 gas, reversible reaction, giving N2O4 gas. When the mixture reaches equilibrium, it is found that the NO2 concentration is 0,4 mole per decimeter cube. The equilibrium constant for the reaction at the temperature at which the equilibrium mixture is maintained is 4. Find the unknown amount of N2O4 taken in the vessel. Solution. We shall use a Rice table to organize the given information and the information required to be calculated. The reaction ρ gives the balanced chemical equation. The initial amount ρ lists the initial amount of substance, mole, of each of the reactants and the products. The change in amount ρ is the amount of substance, mole, that was used or formed in the reaction from the start to the attainment of equilibrium. The equilibrium amount ρ is the amount of substance, mole, of each of the reactants and the products at equilibrium. The equilibrium concentration of each of the reactants and their products is calculated using the equilibrium amount and the volume of the container. We first write the balanced chemical equation in the first row. 2NO2 gas, reversible reaction giving N2O4 gas. The initial amounts are filled in. The amount of N2O4 is unknown and represented by X. We do not know the change in the amount yet. The equilibrium amount of each species is also not known yet. The equilibrium concentration of NO2 is given. The equilibrium concentration of N2O4 needs to be found. Recall the relationship. Concentration, C equals N over V. We can find the number of moles of NO2 at equilibrium, given the equilibrium concentration. N equals 0,4 times 4 equals 1,6 mole of NO2. Let us place this in the Rice table and calculate the other values using this. The equilibrium amount is the final amount. Subtracting the initial amount from the final amount gives the change in amount. Therefore, change in amount of NO2 equals 1,6 mole minus 4 mole equals negative 2,4 mole. The negative sign indicates that NO2 is used in the reaction. Using the stoichiometric coefficients of the reactants and products, we can determine the amount of N2O4 produced in the reaction. 2,4 over 2 equals plus 1,2 mole. The positive sign indicates that N2O4 is produced in the reaction. The equilibrium amount of N2O4 can be found by adding the change in amount of N2O4 to the initial amount of N2O4. Therefore, the equilibrium amount of N2O4 is X plus 1,2. The equilibrium concentration of N2O4 is found using the equilibrium amount of N2O4 and the volume of the vessel. Therefore, the equilibrium concentration of N2O4 is X plus 1,2 over 4. The expression for the equilibrium constant for this reaction can be written Kc equals concentration of N2O4 over concentration of NO2 to the power 2. Substituting the given value of Kc, we get, solving for X, we get X equals 1,36 mole. The initial amount of N2O4 taken in the reaction vessel was 1,36 mole.
Starting to feel it? Now go master it with Maski.